I am Anil Kumar. Welcome to my series on partial fractions. We'll take 5 examples here, talk about how to write a rational function with partial fractions. This is a very important exercise for those who want to do integration by splitting a fraction into partial fractions, and also for students who want to write series with binomial expansions. Now let us see what are the basic concepts. The very first example has x plus 2 over 1 minus x over 4 plus x in the denominator. Now these are basically linear factors in the denominator, and this could always be written as ax, or we can say it could be written as a over 1 minus x plus b over 4 plus x. So we could actually split this in that form. This is done when we have something with linear factors in, we'll write d for denominator. Now in the second example, we have x squared plus 4 divided by x squared minus 1. So at time, you may have to factor the denominator, right? So if you factor the denominator, in that case you get 2 factors here, right? You could also divide the numerator by the denominator and then do the needful. So if the degrees are same as it is in the case of b, it could be a worthwhile exercise to write this as 1 plus, because you could divide this, you'll get some number 1, right, in this case, plus a over x plus 1 plus b over x minus 1. Now this is a different strategy where you have numerator denominators of the same degree. So if it is same degree or higher, we may have to divide, and then the second policy which we have to do here is to factor denominator. And that is how you might get your result. The next example here is 4 over x plus 2 times x squared minus 1. So as you see, x squared minus 1 could be written as x plus 1 times x minus 1. And therefore, I could write this as a over x plus 2 plus b over x plus 1, sorry, just 2, plus c over x minus 1. So these factors x plus 1 and x minus 1 are because of x squared minus 1. So if you have something in the quadratic form in the denominator, that should be factored before writing the partial fractions, right? So always we'll follow the same thing, factor denominator. Now we have an example where again we have a x minus 2 as a double linear factor square, right? So here the principle is slightly different. You will have factors, partial fractions in the form of a over x plus 3 plus b over x minus 2 plus c over x minus 2 whole square, right? So when you have a power of a linear factor, in that case, that results into 2 partial fractions as shown here. The third example is the one in which you have a form of a factor, quadratic form, which cannot be factored. So in that case, what we get here is a over x plus 1 plus, now x squared plus 1, we could have bx plus c as a numerator, since 1 degree lesser, and we have to always use a general form. So we get bx squared plus bx plus c divided by x squared plus 1 as the other factor, right? So remember, to use general form, 1 degree lower. In numerator. So we'll actually elaborate on these strategies and see how to do partial fractions for the given rational expressions. Let's begin with the very first one, which is x plus 2 over 1 minus x times 4 plus x. Now this can be written as a over 1 minus x plus b over 4 plus x. Now we can have two different strategies to solve such questions, right? Rather, any of such questions which we have been discussing, right? So in this part, we'll discuss both these strategies. One way is that we just cross multiply and we can rewrite this as x plus 2 over 1 minus x times 4 plus x equal to, when we take a common denominator, we get 1 minus x times 4 plus x. So denominators are same. In the numerator, we get a times 4 plus x plus b times 1 minus x. Now since the denominators are exactly same, we can say that x plus 2 should be identical to a times 4 plus x plus b times 1 minus x. The symbol here we have used as an identity. This is true for all conditions, right? So this is an identity true for all values of x. Right. So that is the meaning of the symbol here, right? So we may or may not use it, but it is better to use. Now at this stage, we can compare the coefficients for x and the constants to get our solution, right? So you could write this as x plus 2 is congruent to, when you open this, you get 4a plus ax plus b minus bx. So combining the terms with x and with the constants, we get 4a is a constant, ax minus bx. So you could take x common and write this as a minus b times x, right? The constants here are 4a plus b. And that is congruent to x plus 2. Now that really means that this could be true if a minus b is equal to 1 and 4a plus b is equal to 2. Do you get the idea? Right? So this is true when, let's take it over on this side. So we're going to solve this equation. So this is true when a minus b is basically equal to coefficient of x, which is 1, and 4a plus b is equal to 2. So that is how we get two equations from which a and b can be calculated. Now, if you add these equations, right, in that case, you get 4a plus a as 5a equals to 3, or a equals to 3 over 5. Well, you also see that a minus b equals to 1 really implies that b is equal to a minus 1. So we can find the value of b also. So b is equals to a minus 1. A is 3 over 5. So what we get here is 3 over 5 minus 1. So b is minus 2 over 5. Is that clear to you? So you get the values of a and b, and therefore now you can write this rational expression as x plus 2 over 1 minus x times 4 plus x as equal to, a is 3 over 5. We wrote this as a over 1 minus x, right? So we get 3 over 5 times 1 minus x. And b is minus 2 over 5, so we get minus 2 over 5 times 4 plus x. Perfect. So that is how you could actually get your solution. So I hope the steps are absolutely clear. Now here is an alternate way of solving this equation. We might use this solution many times. So we'll actually solve the equation given to us, which is x plus 2 is congruent to a times 4 plus x plus b times 1 minus x. Now in this equation, if I substitute x equals to 1, right? If I substitute x equals to 1 here, then what happens? We get 1 plus 2 equals to a times 4 plus 1 plus b times 1 minus 1. Now 1 minus 1 is 0, right? And therefore, we get 3 equals to 5a, which gives you the value of a as 3 over 5. Clear? We're going to substitute x equals to minus 4 to get the value of b, which we are going to do now. So if I write x equals to minus 4 will make this 0. So we get minus 4 plus 2 equals 2. This part is 0. So we get b times minus and minus becomes plus, right? So we get 1 plus 4. So 5b, right? So here you get minus 2 equals to 5b, and that gives you the answer that b is equals to minus 2 over 5. Is that clear to you? So that's an alternate method which can be always utilized to solve such an expression. I hope it makes sense. Now let's take another example where we have partial fraction of the kind x squared plus 4 over x squared minus 1. I'd like you to pause the video and answer this part of the question and then look into my suggestions. Look into this expression, which is x squared plus 4 over x squared minus 1. Now, since the degrees of numerator denominator are same, we can simplify easily by writing it like this. X squared minus 1, but we need 4, right? So plus 5 over x squared minus 1. And that gives you x squared minus 1 over x squared minus 1 plus 5 over x squared minus 1. Or you can write this as 1 plus 5 over x squared minus 1. Does it make sense to you? So we kind of simplified this, as you have seen, correct? Alternately, we could also do like this. You could divide the numerator by the denominator, right? X squared plus 4 divided by x squared minus 1. It goes one time, so one whole. And when you say x squared minus 1, when you take away, you get 5 as your remainder. So again, you get the same equivalent expression. Does make sense to you? So you could also divide and get the result shown here. Now this process of division should be done definitely when the degree of the numerator is higher, right? Okay, so now what we have really is that we could write this as x squared plus 4 over x squared minus 1 as 1 plus 5 over x squared minus 1. Now whenever you have a case like this where the quadratic factor in the denominator can be factored, you need to factor it. So we could write this as 1 plus 5 over x plus 1 times x minus 1. Does make sense to you, right? Now, we'll use the technique which we used earlier in our previous example, right? So that could be written as equal to 1 plus. So we could write this as a over x plus 1 plus b over x minus 1, correct? Now this is equal to 1 plus. We get x plus 1 times x minus 1 in the denominator, cross multiply. We get a times x minus 1 plus b times x plus 1, right? Now these two expressions are identities, right? They are actually, let's write equal, right? But their numerators can be matched. So from here we can write that 5 is congruent to a times x minus 1 plus b times x plus 1. Do you see that? Now we can compare the coefficients and get our solution. Now from here we can write 5 is congruent to, as far as the x terms are concerned, we have a plus b times x. As far as the constants are concerned, we have minus a and plus b, right? So let me write this as b minus a. Is that clear? Now that gives you two equations to solve. The two equations here are, when you compare them, that a plus b should be 0, right? And b minus a is equal to 5. If you add them, let's call these as our equation number 1 and 2. If you add them, then what do you get? If you add these two equations, what you get is a's cancel, 2b equals to 5, or b equals to 5 over 2. Clear? Now from here we know that a is minus b, right? A equals to minus b. So we get here a as equals to minus 5 over 2. And therefore, we could write the given expression as 1. A value is minus 5 over 2. So minus 5 over 2 times x plus 1. That is what we wrote, right? For a, plus 5 over 2 x minus 1. Does it make sense to you? So that is how we are going to do partial factoring of the given expression. Clear? Let's take up the next example. Now in this case, we have 4 over x plus 2 divided by x squared minus 1. So that is relatively simple. I'd like you to pause the video, answer this one, and then look into my suggestions. So we'll first factor the denominator completely. So we have this as 4 over x plus 2 times x plus 1 times x minus 1. All right. So this expression, which is 4 over x plus 2 times x plus 1 times x minus 1, can be written as a over x plus 2 plus b over x plus 2, right? X plus 1 plus c over x minus 1, right? Now, you could multiply with a common denominator, and what you get here is 4 over x plus 2 times x plus 1 times x minus 1 equal to a times these two terms, which is x plus 1 times x minus 1, plus b times those two, which is x plus 2 times x minus 1, plus c times these two, which is x plus 2 times x plus 1, correct? Divided by x plus 2 times x plus 1 times x minus 1. Now to get our equations, what we are going to do is we'll substitute x equals to, let us say we want to make this 0, right? So we'll substitute this as, let's say, minus 1. So when I substitute x as minus 1, that is 0, right? The last one is 0. We are left with the value of b, right? So we get 4 equals 2. Minus 1 here will give us b times minus 1 plus 2 is 1 times minus 2. And that gives you the value of minus 4 over 2 for b. So b is minus 2 for us. Clear? Now let's substitute x equals to plus 1. So if I substitute x equals to plus 1, then this term is 0. This term is also 0. We get the value for c. Constant 4 now is equal to, substituting 1 here, we get c times 3 plus 3 times 2, right? So c is equal to 4 divided by 3 times 2. So the value of c is 2 over 3. Now, substituting x equals to minus 2, we get the value of a. Since minus 2 will make these two terms 0. So we get the value as 4 equals to, 4 is this constant, minus 2 for x. So we get minus 1 times minus 3. So the value of a will be 3 times 1, 3. So 4 divided by 3. Is that clear to you? So that helps us to give us a, b, and c value. And therefore, we could write this expression as equal to, so we can write this here as 4 over x plus 2 times x squared minus 1 equals 2. The value of a is 4 over 3, right? So we get 4 over 3 times x plus 2. Value of b is minus 2. So we get minus 2 over x plus 1. And the value of c is 2 over 3. So we get plus 2 over 3 times x minus 1. So that becomes our answer. Is that clear to you? So that is how we could do partial factoring of rational functions where the denominator needs to be further factored. Let's take up the next question now for practicing. Now in this case, we have a quadratic function in the numerator and we have a double root, a factor, double factor here in the denominator, and let us see how to solve such a question. Now here is a very interesting question. We need to partial factor 2x squared minus 10x minus 3 divided by x minus 2 whole square times x plus 3. Now in this case, this could be written as equal to a over x minus 2 plus b over x minus 2 whole square, right? So this term leads to two terms plus c over x plus 3, right? So we can now write that 2x squared minus 10x minus 3 over x minus 2 whole square times x plus 3 is equal to same common denominator, right? So let me just draw a line here with the same common denominator, which is x minus 2 times whole square, right, times x plus 3. Now a will get multiplied by x minus 2 plus b times x plus 3 plus c times x minus 2 whole square, correct? Sorry, whole square. So now, since the denominator is the same, we can write that 2x squared minus 10x minus 3 is actually congruent to all this. So here we have, let's open the bracket, we have ax minus 2a plus bx plus 3b, and you need to expand this. Let me just first expand and then we'll multiply. So we get x squared minus 4x plus 4. So while we multiply, we can actually rearrange also. So we have one term with x squared, so that is cx squared. As far as the x terms are concerned, let's write x here. We have a plus b, and in this case it is minus 4c. Now as far as the constants are concerned, we have minus 2a and then plus 3b and plus 4c. Correct? Comparing that is congruent to 2x squared minus 10x minus 3. We can write three different equations. Coefficients of x squared, c. So we get c is equals to 2, right? So we already get the solution for c, which is equal to 2 by comparing these two. Correct? Okay. Now we get an equation which is a plus b minus 4c equals to minus 10. Since we know c is 2, we get a plus b minus 4 times 2, which is 8, minus 10, or we get a plus b equals to minus 10 plus 8, which is minus 2, right? Now, let us also compare the next coefficient, which is minus 2a plus 3b plus 4c is equal to minus 3. Now c is 2, so we can write this as minus 2a plus 3b, c is 2, so that means 4 times 2 equals to minus 3, or minus 2a plus 3b is equal to minus 3 minus 8, right, which is minus 11. Correct? So we have a term which says a plus b is minus 2 and minus 2a plus 3b is minus 11. So we can write from here that a is equals to minus 2 minus b. Substitute in this case, we have to solve somehow, right? So minus 2, a value is minus 2 minus b. So we get minus 2 minus b plus 3b equals to minus 11. Opening this bracket, we get 4 plus 2b plus 3b equals to minus 11. And that is, let's take it on the right side, 2 plus 3 is 5. So we have 5b equals to minus 15. Or b is equals to minus 15 by 5, which is minus 3. So we get b equals to minus 3, and a will now be equal to minus 2 minus of minus 3, right? So which is equal to 1, correct? So we get value of a as 1. And therefore, we can write down that in our case, the rational expression 2x squared minus 10x minus 3 over x plus 2 whole square times x plus 3 is indeed equal to, a is 1 for us, so we have 1 over x minus 2, b is minus 3, so we get minus 3 over x minus 2 whole square, c is 2 for us, so plus 2 over x plus 3. Is that clear to you? So that is how we can write this rational function as partial fractions. Now here is the last question for you to try. So what we have here is relatively a simple question. 2 over x plus 1 over x squared minus 1. Now here what you note here is that this particular is a quadratic factor, right? So we have a quadratic factor. In denominator. So here, when you write this as a partial fraction, the numerator should be a linear portion, correct? So that's kind of important. So we'll write down this as 2 over x plus 1 times x squared plus 1, it cannot be factored, as a over x plus 1 plus b over, rather bx plus c over x squared plus 1. Since x squared plus 1 is in the denominator, the numerator should be a linear factor, right? Now we'll apply the same strategy. So we can write from here that 2 is equal to a times x squared plus 1 plus bx plus c times x plus 1, right? That's what we get. Now, to get our equations, what we can do is we can expand this and then write the like terms. So what we get here is ax squared plus a bx squared plus bx cx plus cx and plus c. Right. Now we can compare the coefficients. So clearly from here what we get is the x squared terms. Let's rewrite. So 2 equals 2. Combining the x squared terms, we get a plus b x squared, right? Combining the x terms, we get b plus c x, and the constant here is a plus c. So the equations which we get, since the constant 2 is there, a plus b should be equal to 0, b plus c should also be equal to 0, and a plus c should be equal to 2. So these are the equations to work with. Correct? So from these two, what we get here is, if you do minus, so we get b minus a as equal to minus 2. And here we have a plus b equals to 0. Now if I add these two equations, right, in that case we get 2b equals to minus 2, and that gives you b as minus 1. Okay? So once you get one value, we can actually get the others. So solving, we get the value of a. So we have b equals to minus 1. A will be equals to minus of b, right? A is minus b, so it is plus 1. And c is equal to, again, minus b, right? So c is also plus 1. And therefore, we could write the expression as, we'll write this as, we have here 2 over x plus 1 times x squared plus 1 equals 2. A is 1 for us, so we get 1 over x plus 1 plus bx plus c, right? So the value of b is minus 1, right? So we have minus x, and the value of c is plus 1 over x squared plus 1. Is that clear to you? Correct? So that is how you could write, or you could write this as 1 over x plus 1 minus x minus 1 over x squared plus 1. Is that clear to you? So that is how we could write the given rational function as partial fraction. Perfect? So with that, we complete our exercise. We did 5 different types of questions in this particular video. I hope that helps you to summarize how should we tackle such questions. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.